I'll introduce our next speaker, Todd Shields. Todd Shields is a graduate of Rose-Hulman Institute of Technology in Terre Haute, Indiana. Todd has worked at the Indiana DOT ever since and currently serves as the statewide asset management engineer.
Good afternoon, everybody, or good morning. I think Phil kind of mentioned this way back pre-COVID when we were planning on doing this meeting in person. One of the things we always do is every state gets up and gives a talk about some success story or some cool thing that they did the previous year. We thought this year we'd change it up and maybe talk about some things that didn't go so well, because a lot of times we learn more from our failures than we do our successes. So hopefully from what John just talked about and what I'm going to show you, you can learn maybe a lesson or two that we had to learn the hard way. Take a second here, talk about what I'm going to do. Talk about the evolution of our chip seal program here in Indiana. I'm going to go back to a 2008 research study, and that has relevance to what we're doing today. So I'll try to tie that all in, and then talk about specifically the State Road 35 chip seal that did not go so well. Just a little bit about our program. Our formal program was initiated in 2009. We called it our Pavement Preservation Initiative. Since that time, we've done lots of training in the area of chip seals. We've developed some field tests, lab tests. We have a application rate program for designs to get our rates set correctly. I think most states have that now. Chip seals are one of our highest priority items. As you can see from the graphic there, we do quite a bit of chip seals. We've ramped up. We're doing about 1,500 lane miles a year. This last year, we did a little bit more than 1,600, so quite a bit. Go back to the study that was done in 2008. This is as we were anticipating ramping up our chip seal program. At that time, we only had a couple districts that even did chip seals, very inconsistent, really no central theme to project selection, certainly weren't geared up from an equipment standpoint or to even really know what we're doing. So this study developed our what we called iSeal, which is our design program, looked a lot into application rates and specifically calibration and measurement, because what good's having a target application rate if you don't know what the equipment's actually putting on the road. Part of this study was field work. So we had to actually measure the different application rates to see how they performed. So this gave us our first, at least in my tenure, our first real good chip seal disaster. This road was in north central Indiana, very straight, very flat road. So the way this worked, you see that's a picture of a milepost. So we had a matrix of application rates, stone and emulsion. So there was me and there was one researcher from our research division that were on the job, and we would stand at the mileposts, and as the equipment went by, we would tell the operators, you know, okay, go to stone rate of this, emulsion rate of that. And so from our end, we were only seeing the front end of the job, or the first mile as we leapfrogged along. We weren't seeing what was going on behind us downstream. So that the flagging crews were leapfrogging as well, and we started hearing, hey, you need to go back and look at what's going on behind you. And we did, and we were not real happy with what we saw. So what you're not seeing in the pictures here, there was a lot of trucks on this road, and turns out this was a detour route. There was another route that was closed, and so this was the signed detour. So a lot of trucks were on this road that we weren't anticipating. For those of you who've made snowmen in the wintertime, you know, you roll the snowballs up. That's exactly what was happening on our chip seal. The chip seal was rolling up on the truck tires, and it was really, really ugly. So the first thing, you know, we panicked, of course. So the first thing we thought of, well, let's close the road, because that would be the easiest thing. Of course, this was already a detour, a signed detour for a closed route, so we were not able to, that wasn't an option for us. So we tried going back, send the chip box back, put some more chips on it. That didn't really work for us. So we ended up sending the snowplows, bringing snowplows out on the job. We actually peeled the chip seal off as best we could. That left a gooey mess. So we sanded the heck out of it. So that got us by until we could figure out what we were going to do to fix this. Certainly not the result we wanted, and certainly not the result you want when central office engineer and your research engineer are out there on the job. So what did we learn? Well, when you're doing a research project, there's a lot of unknowns. So leave yourself an escape route, which we didn't do. Make sure you've got a way to close the road down. Make sure you've got a plan for what to do if something starts going wrong. We didn't have any of those things. So lessons learned here is just have a good fix ready. We ended up going back and re-chipping that road, at least the one direction that we completed, and we survived. Not the best result, but we got through it. A lot of tort claims on that job, just a lot of not looking good from a public motorist standpoint when we're trying to ramp up our chip seal program. So brings us to now, fast forward to this spring. This was actually in May this year. State Road 135, this is in south central Indiana, so opposite side of the state. Some of you guys have heard us talk about road categories. We categorize our roads in Indiana, one of 6 categories, and our C2s are our chip seal routes. So this was a road category C2, ADTs 3,000 to 4,000. So a little bit on the high side. You know, we typically try to stay away from anything over 5,000 ADT. So this was getting a little close, but not abnormal. Not a lot of trucks on this road. Very rolling terrain. Southern Indiana, very hilly. About a 6-mile job, so 12 lane miles. We used what we call SC11, which is about a 1/2-inch top size limestone material we've used for years from a source that we've used for years. And then our emulsion here is CRS2P. So we have 2 of our 6 districts use CRS2P. The other 4 use an anionic still. So this particular material comes out of Terry Asphalt, which is near Cincinnati. Shoulders were done on May 4th on this road, and then the main line was done on the Thursday, May 7th. Cross section of this road, if you guys are familiar with the Super 2, it's 2-lane road, 12-foot lanes, and then 10-foot paved shoulders. So that's why the shoulders were chip sealed separately, because they're almost their own lane. This was a Thursday. Early the next week, we started hearing there were problems. And we started hearing things like the stone wasn't adhering to the binder, the brooms took all the stone off. It's like the binder isn't sticky. So you can see from this was the initial pictures that were sent to us. Most of the stone is on the shoulders, so most of the stone came out. And initial reaction when we see things like this is that we didn't use enough emulsion, or we didn't put enough emulsion on the road, so there wasn't enough to actually hold the stone, and all the stone just comes off. We've seen that many times. So my gut reaction was same thing here, just didn't use enough emulsion. Normally on something like this, when you're trying to backtrack and recreate what actually happened, you're going off the actual work orders, which isn't the best way to do it. That's an actual example of a work order from this job. So fortunately, this particular district, they keep exceptional records. This is nothing that they did after the fact. This is what they do when they're actually building the job. They keep track of which distributors are out there, where they shoot, what their shot rates were, what times, and then what delivery tanker they were actually pulling off of. So we can see exactly what rates were put down at each section of road. So they were shooting for 3,600 gallons a square yard, and you can see they were right in that range. So this is not just taking the computers from the distributor. They actually stick their distributors, if you know what that means. So distributors come with a pole that has markings on it, where you actually stick the pole down in the tank, and you can see how much emulsion is in it. You know, they verified exactly what they were putting down, and it was right on the money. So that kind of took the application rate theory down a notch. The other thing I'll point out, this was the first road of the season that this district had done. The week before, they'd calibrated their equipment at one of the state prisons, with chip sealed a perimeter road, and that was a great place to calibrate the equipment, train folks who maybe this was their first chip seal job. So this is the week after that. So everything is calibrated, everybody's trained, application rates look spot on, and this was the week after. So it was built the Thursday. The following Friday, we went out there. It's a rainy, nasty day, but this is what it was. So you can see a lot of stone loss. And the arrows I'm pointing in the first picture on the left, we're looking northbound. And in the second picture, we're looking southbound. And you can kind of see from the picture, the stone loss it's not great in the northbound, but we'd probably have lived with that. Southbound, we lost a lot worse than the northbound, and we'll kind of see why later. The weather here, I should have pointed out on the earlier slide, we didn't start chip sealing this road till 10 o'clock in the morning. And the reason was the temperatures were below 60 degrees. So temperatures didn't get above 60 until 10 o'clock that day. So everyone agreed we kind of pushed on the temperatures. They were in spec, but we kind of pushed on it. On-site coring there, you can see from the picture, the thickness of the emulsion is what we expected. So that kind of validated the application rates were correct, but we just lost the stone. So if the application rates were correct, the weather was in spec, we knew the equipment was calibrated correctly, only thing left is material, right? So we had to have material failures. Obviously, this being the first job, not getting a good result, the district was unwilling to go any further until we got this one figured out, what went wrong, because we didn't want a whole bunch of these. Started looking at the material tests. We'd already tested the stone because for the design, you have to run tests on a variety of things, and those had all passed. So we knew the stone was okay. So we started looking more at the binder, the asphalt emulsion. We accept in Indiana our emulsions by what's called a Type A certification. So essentially it's a lab test from the supplier that just says, yeah, everything passed. You can see there on the example what the spec limits are and then what the actual results were. So everything was showing that it passed. Now, Type A certifications are taken at the tank at the supplier. They're not taken at the job site. So we have seen instances where it was good material coming out of the tank, but for whatever reason, the semi truck, the delivery truck may have had some, maybe had a few hundred gallons of something else on it that contaminated it. So we were kind of thinking maybe that was the issue here. So we actually had some of the emulsion left from the job on one of our own distributors. So we were able to pull that and to do our own QA testing. Now, we only have one production lab in the state that's capable of doing emulsion tests, and that's in Indianapolis Central Testing. So we knew it was going to take several days to get that sample up to Indianapolis, get them geared up and set up and actually run the tests. We contacted the supplier, which was Terry, and for those of you in the Midwest anyway, Pierre is one of our directors. So Pierre was actually out there the following Monday to look at it with us. And he'd done his homework. He'd spent his weekend pulling QC tests from the lab and talking to people and trying to figure out, was there anything from their end that was a problem? And he couldn't find anything. But he did start looking at the weather reports, and he pointed out that, yeah, the weather wasn't great the day we did this, but did we look at what happened the next few days? And we'll get into that. Back to the material testing. We kept coming back to this idea of stickiness, right? There's no standard test in our spec book about stickiness. So we remembered that 2008 research study which did a lot of lab testing, and our research group actually had bought the materials and to do what's called a Violette test. And if you're not familiar with that, a Violette test kind of does test for stickiness. It's an aggregate retention test to see how well a certain stone is going to stick in a certain emulsion. We got the samples from the job here, 135, that didn't go so well. And the other job, we had another job in an adjacent district that was done about a week later, performed great. So we got all those samples to research as well and had them run this Violette test. So you prepare the samples as shown in the middle picture there with the whatever application rate you use, and then you put the stone in the material, and then you prepare these samples called Violettes. These are cured in an oven, and then they're soaked in water for so many hours. They're put in a freezer, soaked in water again. So it's simulating freeze thaws. And then you go in and you turn the sample upside down, which is in the apparatus on the right. And let's see if it's going to work. Hope that's coming through okay. So you drop this ball on your sample so many times, and then you measure how much stone actually popped out. So that'll tell you if there's a problem with the stickiness of the binder. So we started getting our own tests back. So Terry, we'd sent some samples to Terry as well so that they could run them, and then our own central testing. Everything was coming back pass. So we were not seeing any problems with the material. And then the Violette test results were coming back, and they showed the different materials that were used. So the job in the adjacent district was using crushed gravel and then the anionic emulsion, whereas this job on 135 had the CRS2P and the limestone. So they did all permutations, variations of the material, the emulsion and the stone, and they were getting almost identical results. About 30%, 20-30% stone loss, which on a Violette test, that's actually pretty good. There was absolutely nothing that we could see from a material standpoint that was a problem. So our application rates were right, materials, no problem. So got us going back to what Pierre had said about the weather. So if we look a little closer at what actually happened here, this is a graph of the temperatures through time for that day that we did the chip seal. Our specifications say surface and air temperatures both need to be 60 and rising. So the district did what they were supposed to do. They waited for the temperature to get to be 60 degrees. You can see there, 9-10 o'clock, we hit 60. So we started the chip seal about 10 o'clock, finished northbound about 1 o'clock, turned around. Now with CRS2P, one of the nice things is it cures faster. You can get the brooms on it quicker. So we say at least 2-3 hours, let it cure, and then you can have the brooms at it. So we waited about 4 hours, and then we started brooming the northbound. So turn around and we finished the southbound chip sealing about 5 o'clock. Now, in talking to some of the folks on the job, we found out that the brooms started at 2 o'clock, which was okay, but they didn't stop. They turned around when they got to the north end and started brooming southbound, and they actually caught up to the operation. So it certainly didn't cure 2 hours before they were brooming on the southbound. And as you can remember, the pictures I showed a few slides back, definitely saw more stone loss on the southbound than the northbound. So our temperature profile here, yeah, we got above 60, but you can see if we got down at 5 o'clock, within a couple hours, we were below 60 again. And then that night it rained. Well, then what happened? Well, this was Thursday, so we got down to about 50 in rain that night. The following day, Friday night, we got down below freezing. Saturday was chilly, and then Sunday again, we got really cold, close to freezing again. It looked like what Pierre had pointed out had to be our problem. So how do we fix this? Fortunately, if you can say fortunately on a job like this was May. So when you have a problem with the chip seal in May, you've got a lot more options than you do had this happened in late September, which is more often than not the case. So we were able to think through what's the best solution, and we finally determined let's just mill it off. So we've got some experience now doing fine mills and micro mills on chip seals. In the time frame we had here, we were only able to do a fine mill, which not a micro mill. So this is what it looked like. We milled it off. You can see from my calibrated fingers there on the left, kind of what the texture was like. We wanted to re-chip it, but before we did that, we wanted to make sure it was going to perform. So we did a test strip, about a mile long. And this is a picture right after the test strip was down. Hadn't been fog sealed or anything. We just wanted to put the test strip down and let it go for several weeks before we made a decision on chip sealing the whole road. And the test strip did perform. So we went ahead and chip sealed the entire road. That was back in July, I believe. So a couple months, 6 weeks after the original. So what did we learn from all this? Well, first of all, CRS2P, like I said, this district had been using CRS2P for 4 or 5 years now. They pushed the envelope, and we learned that CRS2P does not make you bulletproof. You still have to watch temperatures. You still have to watch what's going to happen in the future. So the next few nights, you do not want to get below freezing for 2 to 3 nights after a chip seal goes down, and we did not have that case here. Not only did it rain the first night that it was down, but then we got below freezing the next night. So almost like that Violette test. We were way too aggressive on the brooming, especially the southbound. You know, with the brooms caught up to the operation. You do not want that. You want to let this cure several hours before you have the brooms on it. So this is the pictures you see there, what it looks like as of last week. You definitely see some flushing still, and that's not stone loss this time. That's a little bit of flushing. You can see from the picture on the left, it's not that bad. There's still some texture there. just guessing, is because of the fine mill. I think what you're seeing is probably the aggregate is getting pushed down into that texture. And so we're getting a little bit of flushing in the wheel pass, but I think we're going to live with this. So with that, go ahead and conclude. I think, like Phil said, we're saving questions until the end. So if you've got questions, send them through the chat box and we'll try to get to them at the end.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.